Good evening, everyone, and this is lecture number, what should I say, 4. And we were dealing with forces and conservative forces. Yes or no? We were dealing with force. We had seen the relation between force and potential energy, and we were talking about the stable equilibrium and unstable equilibrium. Yes or no? Everyone knows this, what we were talking about?
Yes, sir.
Stable equilibrium, unstable equilibrium, and the relation between conservative force and potential energy. This is the relation that we have, and we have a graph. We have a graph between potential energy and x. From this graph we can find out the force. Remember, force is the negative gradient of the graph. Do we understand this?
Yes,
Force
sir.
is negative gradient of the graph. Now how they are going to ask you about the positive and the negative gradient? Let us draw the diagram again. So I'll show you a diagram again, and then I'll tell you, because this is the type of question that can come in the examination also. I will keep this diagram ready here on the left hand side, and then we can understand what do you mean by positive gradient, negative gradient, and so on. So this is the graph of potential energy versus x. We remember this graph, yes or no? Now, from this graph, we can find out the nature of the force, whether the force is attractive or whether the force is repulsive. How do I find it out? How do I find it out? So, this is how you find it out. Now, remember, force is the negative gradient of energy. Yes or no?
Yes.
Okay. Now, what do you mean by gradient? What do you mean by gradient? Gradient is a derivative. If on increasing x, u increases, if on increasing x, u increases, then the gradient is positive. We understand this.
Yes,
If
sir.
the gradient is positive, force is negative. We understand this. Force is negative, that means it is attractive in nature. It is trying to pull you back. Do we understand this? This region is represented by BC. This is the region where force is attractive. This is what I wanted to show you, my dear friends. This is the region of attractive force. So if I push you away from B towards C, you will not go towards C because force will try to pull you down. Do we understand this?
Yes, sir.
Okay. Now, when do we find out that the force is repulsive? So if you do the ulta of this, you will find out that the force is repulsive. What do you mean by ulta? What do you mean by ulta of this? If on increasing the value of x, if on increasing the value of x, the value of u decreases, du by dx will be negative. That means your force is positive. That means force is repulsive in nature. This is the region where force is repulsive. So what happens here is, when you are at point A, it is being pushed towards point B. That means the force is in this direction. This is what I'm calling as repulsive. When the force is in this direction, I call this as attractive. Do we understand this?
Yes, sir.
So basically what it means is, if I am pushing you away from the point B, whether I put it towards C or I put you towards A, you're always going to come back to B. Do we understand this?
Yes, sir.
Therefore, this point B is known as the point of
Stable.
stable equilibrium. And at this point of stable equilibrium, you can see potential energy is minimum. Do you see this? Yes or no?
Yes, sir.
Now look at this gentlemanly point C. Now at this point C, what happens? If I push you, you will fall down on this side or you will fall down on this side. That means as long as you are on C, everything is okay. But as soon as you move slightly, you will just fall down. That means this is a point of
Stable.
unstable equilibrium. You will not come back to point C. Point B, if I push you, you will again come back to point B. But point C, if I push you, you will just go down. This is the point of unstable equilibrium. Your potential energy is maximum. Do we understand this? Yes or no? No, yes.
Yes, sir.
If I have a point where the slope is 0, if I have a point where the slope is 0, for example, if I make it here only, if I make it here only, let me make it this way, that if the if the line is flat, and if you are here at this point, even if I push it, you don't go anywhere, you just keep on moving here. This is a point which we call of neutral equilibrium. Do we understand this? This is a point of neutral
Neutral
equilibrium.
equilibrium.
This is a point of neutral equilibrium or zero force. There is no force acting on it, and you are at a point of neutral equilibrium. Do we understand this?
Yes, sir.
Neutral equilibrium. I will just show it to you here. This is the point where no force acts on it. When you change, when you increase x, nothing happens to you. You remain same. That is the point of neutral equilibrium. There is no force acting on the particle. Do we understand this?
Yes, sir.
Now, if you want more on this, I have this table that I am going to show it to you. You can note them down point by point. You can note them down point by point, side by side in a column form. So this is how they go. The first one is your stable equilibrium. When a particle is displaced slightly, it will always come back to its initial position. Potential energy is minimum. Force at this point is 0. Second derivative of u is positive. The rate of change of u is positive. So these are the things mathematically we can prove it. For unstable equilibrium, when the particle is displaced slightly, it will never come back. It will go to the stable equilibrium. Potential energy is maximum. Force at this point is also 0. At all stable, unstable, and neutral equilibrium, forces are 0. When you are in stable equilibrium, if someone pushes you, force will start to act and you will come back. Force will start to act, you will come back. And unstable equilibrium, if you are there, if someone pushes you, you just go down. Do we understand this?
Yes, sir.
Second derivative is negative here. That means the rate of change of u is negative. In case of neutral equilibrium, there is no force. Whether you push it, you are here, no force, you are here, no force, you are here, no force. Force is 0. The rate of change is 0. Everything is 0. Do we understand this? If you want to note it down, you can note it down. And the best way to understand this is here. So once you note it down, I will show you these examples, and these examples are the best way to understand what I am saying here. So let me know once you are done. Once you are done with point 1, let me know so that I can just shift the screen and show you the other points.
Done, sir.
Done, sir. Then I will just move it slightly to show you the same thing in the form of a diagram, and this diagram will make you understand what I am saying. This is the point of stable equilibrium. As long as you are here, as long as that you are at the lowest point, there is no force. But if I push you upwards, the force will act in this direction. If I push you on this side also, the force will act in this direction and you will come back. Do we understand this?
Yes, sir.
If you are on the top, bacha, as long as you are here, no problem. If I push you here, you don't go, you don't come back, you will just move down. If I push you on this side, you will not come back, you will go down. So this is the point of unstable equilibrium. You are at the highest point. Once you are at the highest point, the only way you can go is down. Once you are at the lowest point, that is the lowest point of your life. You will always come back to the lowest point no matter what happens. Third point, neutral equilibrium. If I push you here, if I push you here, no matter, no force acts on you. So stability means minimum energy is also valid in your life. If you earn a lot of money, you are very unstable. You keep on wandering here and there. If you earn somewhat less, you are more stable. No one can push you away. I'll give you 2 minutes to note this down.
Done, sir.
Everyone has done this?
Yes, sir.
Okay. That takes us ahead in life. We have understood the concept of neutral, stable, and unstable equilibrium. Let me give you one or two questions on this. Which one should I start with? I think this is better for me to start. Let me start with this one. This is a question that was asked in one of the BHU exams. I don't know. As soon as I say BHU, that means IIT BHU. In my times, it was not IIT. So it used to have its own exam. A few days ago, I went to Banaras and I went to BHU. And it's a fabulous place right in the heart of the city. The potential energy of a body is given by A minus BX square, where X is the displacement. What is the magnitude of force acting on the particle? You have 2 minutes to give me the answer.
Sir.
Yes, bacha. What is the answer?
Option B, sir. Proportional to X.
Option B, proportional to X. And how did you get the answer? We just have to do simple things correctly. And what is the simplest thing? F is minus du by dx. Yes or no? Yes or no?
Yes, sir.
Differentiate it once and you will get this answer. Right? Not this one. Sorry, this one. And that is the correct answer. Correct?
Yes, sir.
Well, that has given me enough confidence to give you this question, which came in one of the IITs, not the JEE Main, one of the previous IITs, IIT-JEE. A very famous question, and this has the potential to come in the present day IIT as well as in present day JEE Main. And I will just keep shut and ask you to read the question, get me the answer, and stay happy. A particle which is constrained to move along the x-axis is subjected to a force in the same direction, which varies with the distance x of the particle from the origin, as this, where k and a are positive constants. For x is greater than 0, the functional form of potential energy of the particle is. This is more on maths rather than on physics. So here force is given, and you have to find the energy curve. 2 minutes you shall have. Let's see who gets me this one. This is really good. A really good question. And this could very well come in this year's JEE. When I say JEE, this is probably above the level of JEE Main. Definitely above the level of JEE Main. Any answer, my dear friends? Or shall I do it?
Sir, it's B, sir.
It's
B. Second
it's
graph.
it's B. What makes you say that it's B? Any special reason for that?
Sir, I have integrated 4, sir.
You have integrated 4. That is the correct thing that you have done. You should have done that. Then
And
what?
when I substitute displacement as 0 and x is given as greater than or equals to 0, no, sir. So
Okay.
I have substituted 0.
Okay.
Potential difference has come as 0.
Potential difference.
When after integration, sir.
Okay.
And then I have double differentiated it.
Double differentiated it. Okay. What do you get then? So basically, in this question, what you have to do is your force is given as a function of distance. You first have to integrate it. Yes or no?
Yes, sir.
You will get your energy. You will get your energy as a function of x. Yes or no?
Yes, sir.
And then you simply see which equation it is falling into, which equation is which of the curve is satisfying the condition that you are getting. Yes or no? No, yes?
Yes, sir.
That's it. That is what you got to do. And you got the answer as
B, sir.
B. It's not B. Give you 1 more minute. It's about curves. Think about it again. Try it again. I want you to solve it. Because you're on the right track, doing the right thing. I don't want to spoil it for you. When I say spoiling, I mean if I do it and you have done all the hard work, you should get the answer so that you can stay happy. I'll give you 2 more minutes to do this, and I'm sure you can get the answer. If you're not able to understand it by then I will probably tell you the answer, how it is done. Again, it is only looking at the curve, seeing what is there and doing it. Shall I do it?
Yes, sir.
So what is the problem with this? The first step, we are going to integrate it and we will get u as a function of x. Yes or no? What is the value of u as a function of x? Tell me.
Kx square by 2 minus ax power 4 by 4.
Ax square by 2 minus
Ax power 4 by 4.
by 4. Okay. And you are getting your answer as B. Now I straight away see the answer as D. How do I see it?
Okay, sir. Means it depends on K and A, no, sir.
K and A are positive constant, my dear friends. And this is x raised to the power 4. So some point in life, it is going to become negative. Yes or no?
Okay, sir.
Isn't it?
Yes, sir.
So
I have
straight away the
missed,
answer
sir.
is
Okay, sir.
see, just well done, but we just have to just use a little bit more of this, and I'm doing this problem because they are more likely to come both in your JEE Main and JEE Advanced. Similar problem. Let's see if you can do this one. Probably I could have done this one before, but I thought that that problem was simple. In the way, if you understand that at some point it's going to get negative, you will be able to get the answer. Anyway, this one comes for you now. The potential energy of a system is represented in the first figure. The force acting on the system will be represented by which figure? These are the type of questions that are in fashion these days. When I say they are in fashion, I mean these type of questions are coming these days. I'll give you 2 minutes to solve this.
Okay, sir.
Huh? Why is taking so much of time?
Sir, it's C, sir.
It is C, sir. It has to be C. There is no other option which is correct. It has to be C.
Yes, sir.
My dear friends, it is as simple as it gets. Force is the negative derivative of u with x, right?
Yes, sir.
If it is difficult for you to understand in terms of x, you can think it of this way. Acceleration is dv by dt. Here, acceleration is substituted by f, and this dv by dt is substituted by du by dx. The only thing it is negative here. Now this has got a positive slope, yes or no?
Yes, sir.
Positive constant slope, yes or no?
Yes, sir.
And force has to be negative of this, so it has to be negative,
Yes, sir.
right? Now, so there are two options which are negative and constant, but here the force is varying. Force cannot vary because energy is constant, so force has to be zero.
Yes, sir.
Option is C. This is nothing about physics. This is all about math. Do we understand this? Yes or no? No, yes.
Yes, sir.
I'm going to do all types of problems that are possible here because I just feel that this type of question is going to come this year. This is my strong feeling, and this comes the next one. So any question of this nature, you should be able to crack it. Question number 5, I've forgotten the number. A particle moves in a potential region given by Falana. A state of equilibrium will be what? It's a straightforward question with a straightforward answer. Please give me the answer. You have 2 minutes to do this.
Sir, it's done, sir.
What is the answer, sir?
Sir, it's 0.25 meters.
0.25 meters. That is absolutely correct. However, we are supposed to do this. To
Sir,
find the equilibrium, you have to find the position where your force is zero. Yes or no?
yes, sir.
And where is the force zero? Force is negative derivative of u with respect to x. That has to be zero. You find the derivative of u with respect to x.
Yes, sir.
What is the derivative of u with respect to x? It's 16x minus 4. Yes or no?
Yes, sir.
That implies your x is 1 by 4. So x is 1 by 4 is your position of equilibrium. Yes or no?
Yes, sir.
Can I go one more step ahead and ask you what type of equilibrium is this? Is this stable equilibrium, or is this unstable equilibrium, or is this neutral equilibrium?
Sir, it's stable equilibrium.
Why it is stable equilibrium? Guess.
Sir, if you again differentiate it, it is positive.
Yes, you find out the first derivative du by dx. That is a point I wanted to make. It is 16x minus 4. If I double differentiate it, d2u by dx square, it will come out at 16, which is greater than 0. That means this has to be a stable
Stable
equilibrium.
equilibrium.
Do we understand this? This is the way we
Yes,
find
sir.
out the position of stable, unstable, or neutral equilibrium. Everyone understands this? Yes or no? No, yes.
Yes, sir.
Okay. Let me present more problems. This is a problem which has come in JEE many times. So we'll just do it for the sake of doing it. The problem comes on your screen now. The potential energy between two atoms in a molecule is given by A by x raised to the power 12 minus B raised to the power B by x raised to the power 6, where A and B are positive constant and x is the distance between the atoms. The system is in stable equilibrium when? Is it such a difficult question?
Yes, sir.
Huh? No, it is not. It is that simple as it gets. Shall I do it?
Yes, sir.
You have to do the same thing over and over again. How are we supposed to solve this? We find force, which is the negative derivative of u by x. Oops, I have written u by u. So find the derivative. What is the derivative of this coming? Minus 12a divided by x raised to the power 13 plus 6 times b x raised to the power 7. This has to be equal to 0. Yes or no?
Yes, sir.
From here, you can find out the value of x. What is the value of x coming as? 2a by b raised to the power of 1 by 6. Yes or no? Simple maths. What is so complicated here? So complicated?
No, sir.
Then you can find the second derivative and see if this value of x, for this value of x, is it coming positive or not. It's a simple derivative. I hope you know how to solve this equation. Yes or no?
Yes, sir. Yes, sir.
It's simple maths, beta. It does not have anything except for simple maths. Do we understand this, everyone?
Yes, sir.
Every time a question of this nature comes, my dear friends, you have to do the same thing over and over again. This one. Tell me the answer fast. Which of the following cases is not a case of equilibrium?
Sir, it's F.
Yes? Yes, bacha. Which of the following is not a case of equilibrium? And the answer is
F, sir. F.
F, sir, 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 F, sir. Yes, sir, yes, sir, yes, sir, yes, sir, yes, sir, yes. Anyone understand this, sir? We move ahead. With this, just to make you understand that everything is okay in this universe. Next one. The potential energy of a spring is given by half k square, where x is the extension of the spring. What is the force associated with this potential energy? You already know the answer, yes or no? But you can now do it by what you have learned new. Spring force, spring energy is a conservative force.
Yes, sir.
So the relation between force and energy must be there. See what relation you are getting. Fatafat tell me, fatafat tell me, fatafat tell me, fatafat tell me.
Sir, it's positive.
Huh? What positive? F is minus du by dx. Forgotten that? Minus derivative. So it is minus kx. Force is minus kx. Directed opposite to the displacement. That is the answer. You don't know spring force?
Yes, sir.
So what, sir? Okay. Then this is up till now the force was one dimensional. Now we move on to force which is two dimensional. Here you have the next question. The potential energy of a particle in space. Now this question will only come in the domain of JEE Advanced. The potential energy of a particle in space is given by U is x square plus y square. What is the force associated with this? How do you solve this question? Well, to solve this question, you'll have to get back. Remember, this is not a one-dimensional force, this is a two-dimensional force. So you'll have to get back to this formula.
Sir,
You see this?
negative, sir.
What negative, sir? Why you keep on saying negative, sir? Always. We have to go back to this formula of force for a three-dimensional force. To get back to this formula for force, which is the three-dimensional vector form of force, when the force is not along x, it is maybe along x or y. So how do I find out the force with this energy? So force will now be written as minus del u by del x, partial derivative of I, minus del u by del y of j, minus del u by del z of k. You have to find the partial derivative. Do you understand the meaning of partial derivative?
Yes.
So let us find del u by del x, partial derivative of u with respect to x. Now when I say partial derivative, only x is variable and y is constant. Do you understand this? So the partial derivative of x square plus y square, partial derivative of x square plus y square will be a constant, so it will go away. So it is simply equal to 2x. Yes or no?
Yes, sir.
Partial derivative of y with respect u with respect to y will be del by del y of x square plus y square. Yes or no?
Yes, sir.
So this will be 2y. Yes or no?
Yes, sir.
So what is your answer for the force? Your force in vector becomes minus 2xi. Your force becomes minus 2x into I minus 2y into j. Do we understand this?
Yes, sir.
Yes or no? I'll give you 1 minute to note this down.
Yes, sir. It's done.
Then we have this question, my dear friends. And remember, this is not a question of physics. This is a question of? This is a question of?
Mathematics.
Maths. Physics has got nothing to do with this one. Physics is simple. Can't help with maths. That is tough.
Sir, xi cap plus yj cap. Sir.
Think again. There's nothing wrong in thinking. Shall I do it for you?
Yes, sir.
As I told you, this question is more about maths than physics. You just have to find out the partial derivative. You can do that. The answer is there for you to take it. How do I find this out? So what do I need to do is again go back. Force is vectorly minus del u by del x I minus del u by del y of j. Let us find del u by del x. So it is del by del x of xy. Remember, y is the constant. X is the variable. So y jumps out. Del x by x is 1. So you will get y here, my dear friends. You understand this?
Yes,
Y
sir.
is the constant. It jumps out. Bloop. Only x remains here. Del u by del y is what, my dear friends? Del by del y of xy. Now here x is constant. It jumps out. Del y by y is 1. So this is x. So what is the answer for force, my dear friends?
Y I cap plus x.
Not y minus y I cap minus j minus x j cap. Do we understand this? Yes or no? No, yes. Or this is gone above. I'm saying bye bye. I'm going.
Sir, but u is minus xy no, sir.
Huh?
U is minus xy no, sir.
2 is minus xy?
U, sir, potential energy is minus xy no, sir.
Oh, sorry. I did not see it. Sorry. Okay, do we get this? So I should have written minus here. I forgot to write it here. Minus. Do we get this? Yes or no? No, yes.
Yes, sir.
That brings us to an end of this class. In this class, we have done a lot of questions on force, potential energy, and their relations. I hope this is much more than enough that you will ever require. Once force is given, you can actually calculate energy or work done. We have done that, right? To integrate this. Yes or no? That was
Yes,
the
sir.
part where we have not done. So we are done with this. In the next class, we'll move on to the last part of this law of conservation of mechanical energy, and we'll discuss power as well. It might take one class, it might take two classes, but I've always believed in doing what we are doing. We do it to the fullest so that if any question comes, we should be able to solve it. Now I'm confident that if any question comes on this category, you should be able to do it. We'll try to do the same thing with the coming things. Remember, we have less time, but we'll have to cover as much of the course as possible and in as short thing as possible. So I'll see you in the next class. Take care, and next class tomorrow is at your normal time. This was just because of unavoidable circumstances and did not want to lose on a class. Time is a luxury that we don't have. So take care. Have a nice day. Bye bye. God bless you all.
Thank you, sir.